ఎక్స్పర్ట్స్ సలహాలు సూచనలు లేకుంటే విద్యార్థులకు కష్టమే. ఈ అంశాన్ని దృష్టిలో ఉంచుకునే KAB టెలివిజన్ ప్రత్యేకంగా ఉచితంగా ఈ క్లాసెస్ నిర్వహిస్తోంది. ఈ క్లాసెస్లో కలిగే సందేహాల నివృత్తికి ఈ ట్యూషన్స్ కూడా ప్రారంభించబోతున్నామని తెలిపేందుకు సంతోషిస్తున్నాం. ముందుగా ఇవాల్టి మ్యాథ్స్ 2A క్లాస్లోకి ఎంటర్ అయిపోదామా? డియర్ స్టూడెంట్స్, గత ఎపిసోడ్లో మ్యాథ్స్ 2A పేపర్లోని మ్యాట్రిసెస్ టాపిక్కు సంబంధించి లాంగ్ ఆన్సర్ క్వశ్చన్స్ గురించి తెలుసుకున్నాం కదా. ఈనాటి ఎపిసోడ్లో ఇదే టాపిక్కు సంబంధించి షార్ట్ ఆన్సర్స్, వెరీ షార్ట్ ఆన్సర్స్ గురించి తెలుసుకుందాం. ఈ క్లాసును మ్యాథమెటిక్స్ బోధనలో విశేష అనుభవం ఉన్న శేషు కుమార్ తీసుకుంటారు.
Okay, now we are discussing about the VSAQ'S and SAQ'S of the matrices. In this part, especially in the short answer questions, that means actually especially matrices will comes as well as 8 marks, 7 marks, 4 marks and 2 marks. So till now we covered only the 7 marks. Now we want to cover the syllabus for the 4 marks questions, and then I will cover the very short answers questions. So try to understand now. It will cover in all chapters, in all cases. That means in VSAQ'S it will occur, in SAQ'S will occur, and again in LAQ'S it will occur. So try to understand the importance of the matrices. So this is a very important question and a very important chapter also. Right. Now I am taking one question for the SAQ'S. Already we know the some definitions. I am considering some question here. If A is a non-singular matrix, A is a non-singular matrix, it is a non-singular matrix they provided. At that stage, you have to prove that, then prove that A inverse is equal to adjoint A by determinant of A. A inverse is equal to adjoint A by determinant of A. Once again repeating the question here. A is a non-singular matrix, then prove that A inverse is equivalent to adjoint A by that A. So this is the part of that. Or else the same question can be asked as like this. A into adjoint A is equal to, it can be given as some other statement form, A into adjoint A into A is equal to I into determinant of A, or it can be written as det A into I. A into adjoint A is equal to adjoint A into A is equal to det A into I. So that you have to prove that. So you may prove either this one or this one. Actually, to prove this also you have to prove this one. To prove this one, first of all you have to consider. So that's why this question can be questioned as in two ways. Either one way, A inverse is adjoint A by det A, and the another way, A into adjoint A is equal to adjoint A into A is equal to det A into I. So these two ways. Right. Now I would like to prove this, especially I would like to prove this theorem. It's a theorem as well as. Right. To prove this, they given it like this. Let us suppose here they provided, we are doing the proof of this part. In this proof, we are doing like this. Here is the proof of this one, right? We have to assume that let A is equal to, you assume this as A1, A2, A3, B1, B2, B3, C1, C2, C3. It is originally A is this much, A1, A2, A3, B1, B2, B3, C1, C2, C3, a non-singular matrix. A non-singular matrix. I think everybody will know that singular matrix. What is the meaning of non-singular matrix and singular matrix? I am explaining here. If determinant of A is not equal to 0, that's called as non-singular matrix. Once again repeating. Determinant of A not equal to 0, it is called as non-singular matrix. And one more very key point is here. for every matrix to possess a inverse, it should be a non-singular. It should be a non-singular. That means determinant of that particular matrix will not equal to 0. So if it is equal to 0, we are unable to define the inverse. So it's a very key point here. Once again repeating, for every non-singular matrix we can find the inverse, but for every singular matrix we can't find the inverse. And again I am defining the singular matrix. If determinant of A is 0, it is singular. If determinant of A not equal to 0, it's called as a non-singular matrix. Right, a non-singular matrix, we assumed that. Now I would like to write the cofactors matrix. Cofactor of A. That means here cofactor matrix means I am writing here every element of the matrix A replaced by its cofactors. Replaced by its cofactors. Let us suppose, I think by our regular verbal notations and our previous knowledge, we may know that every cofactor of small a1 can be denoted by capital A1. Small a2 can be denoted by capital A2. Small a3 can be denoted by capital A3. Like this. So we write the cofactors of A. Here A1, A2, A3 I am writing here. Similarly B1, B2, B3, C1, C2, C3. Just to denote that I am writing like this. It's a capital letter C. See, once again repeating, here cofactors matrix I am writing. The meaning of this cofactors matrix, here every element of matrix A will be replaced by its cofactors, then it is called as cofactors matrix. Now I am writing A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, you got the cofactors of A. Now I would like to write adjoint of A. Adjoint of A. This is cofactors matrix transpose. Cofactor A's transpose. We call this as a transpose. We have to find out the cofactors A transpose, that is called as adjoint A. This is equal to, I think everybody knows that transpose of any matrix is nothing but, or we know our previous knowledge, our basic knowledge, we may come to conclusion transpose is nothing but interchanging of rows and columns of the matrix. It's a simple concept. Interchanging the rows and columns. Once again I am repeating. Just row of a one matrix will be written in column, that's called as transpose. Right. Here A1, A2, A3. So it is in first row. Can I write it in first column? So this is the part A1, A2, A3. Again B1, B2, B3 in the second row. That I can write it as very clearly as a second column. Similarly, it is the third column. Right. You got the third column. You got the first column like this. So this is our transpose. It is called as adjoint A. Once again repeating, adjoint A is nothing but cofactors matrix transpose. Cofactors matrix transpose. Right. You got the adjoint A and you got the matrix A. Now I have to find out A into adjoint A. So that is my aim. Now my aim is to find it A into adjoint A. See here A into adjoint A I am writing as like this. Here everybody will know that A value, A matrix. Everybody knows that adjoint matrix. See A into adjoint A I am going to consider A into adjoint A. Here A is, you know, A1, A2, A3, B1, B2, B3. Again C1, it is a small c1, C2, C3. Already you know that adjoint A. This adjoint A is A1, A2, A3, B1, B2, B3. Again C1, C2, C3. I think now you understand this part. What I am writing here, adjoint A matrix as transpose of cofactors. Simply matrix A is as easily we considered. Right. I would like to multiply this. Once again we have